Okay, so what we're going to look at for the next portion of the course, for the next portion of today's class at least, we're going to look at finding areas based off coordinates. So we're going to start by looking at a graphed system here. Okay, so let's do coordinates for the endpoints of our stuff here. So here is our figure. Now I don't have a grid drawn in, so you can't see the coordinates real well. This point here is the point 2, 1. This point here is the point, what's this? Is 14, 4. Do you guys remember how we find these coordinates? So this one is 10, 10. This one here, what would be its x-coordinate? 3. And its y-coordinate would be, I gotta pick this 7, I think is what I meant that to be. So 3, 7. So we've got the coordinates. Now this could have more than 4 corners. It could have as many corners as we want it to be. To find its area, I list the points. I'm going to pick a corner to start at. Pick a point to start at. Anybody give me one? 3, 7. We're going to start at 3, 7. And now we're going to list them going down, going clockwise, or sorry, counterclockwise around the figure. So the next point is 2, 1. What comes next? 14, 4. And then, what's the next corner? 10, 10. Have we gone all the way around the figure yet? Not quite. To go all the way around the figure, we have to go back to 3, 7. Now that's very important. You must go back to where you started because you have to circle the whole figure. Once we've circled the whole figure, we do what's called diagonal multiplication. We're going to do the forward diagonals. What's 3 times 1? Not everybody at once. 3 times 1 is 3. What's 2 times 4? 8. 14 times 10? 140. 10 times 7? 70. What's that add up to? 221. Look right? Say yes. Now we're going to do the backwards diagonals. 7 times 2 is 14. You guys see where the diagonals are? You look confused, Mike. All I'm doing is I'm going to the diagonal. The first number of this one and the second number of that one. First number, second number. First number, second number. Going down in diagonals like that. And I'm just multiplying as I go. So now going this way, it's 1 and 14 is 14. 4 and 10 is 40. 10 and 3 is 30. What's that add up to? 98. Very good. So now I find the difference between those two. What's the difference between those two? 221 minus 98 is, say 23. 23. And then I divide that by 2, get 11.5. What's that? 123. Yeah, 123. Very good. Now I divide that by 2, I get 61.5, right? That's square units. I don't have any labels on there for my distances, whether each of those is a foot or a yard or whatever they are. So it's 61.5 square units of area. Why would this be useful for anything? Oh, it's more useful than you'd think. Surveying. You used to have to measure it out, find the corners, and map it out. Well, now you can just use your GPS. The GPS is accurate. If you buy the good GPS, the expensive GPS, they can give you a lattice point, longitude and latitude down to 3 inches. So you just pick a corner of the property. Let's say we have a property that looks some sort of a weird shape like this, right? You just pick a corner of the property, set your GPS to 0, 0. You go up here. It tells you this point is 5, 3. This point here it tells you is 12, 1. This point up here it tells you is 11, 15. And this one here it tells you is 0, 11. So again, I'm going to list out my points. Pick a point to start at. Let's start at 0, 0. Why not, right? What point do I have to do next? I'm going counterclockwise. So 5, 3. What's next? 12, 1. And then 11, 15. And 0, 11. Am I done? We have to go back to 0, 0. We have to circle the whole shape. Now, I'm going to assume that these are laid out in rods. Why? Because most land is surveyed in rods. So now I'm going to do my diagonal products. 0 times 3, 0. 5 times 1, 5. Do you see where those diagonals are coming from now, Mike?
Yeah,
It's kind of a weird process, isn't it?
Yeah, what exactly are you figuring out by doing that?
I'm getting these numbers. It's if you were doing matrices, if you're doing matrices, it'd be part of a determinant. But it's just it's a process that just allows you to find the area based on the coordinates of the corners. So then 12 times 15, 180. 11 times 11, 121. 0 times 0 is 0. If I add those all up, I get 306. Questions? Let's go this way. 0 times 5. 0. 3 times 12. 6. 1 times 11. 15 times 0. 0. And 11 times 0. Those add up to 47. Tell me what to do next. 306 minus 47. Which is going to be, what, 259? So I'm going to divide that by 2. 129.5 square rods. Yeah, but that to get square feet, it would be times 16.5 squared, remember, because it's square feet. So a square rod would be 16.5 by 16.5. Let's do that. 129.5 times 16.5x squared. That's going to be 35,256. Well, how many square feet is an acre? Does anybody remember? 43,560 square feet. So divide by 43,560. So that's 0.8 .809 acres. Probably 0.81 would be what it would be listed as. I think they only go to 2 decimal places when they survey for land, for taxes. So that's not it's a decent sized city lot. 0.8, a little over 0.8 of an acre. Most city lots are half acre or 3/4 of an acre. What do you guys think of this process? Your head hurts? Not much of it? Let's have you guys find the area of this fun little piece of property. We're going to assume that it has like some natural features like possibly water and some other really odd shaped stuff around it, that this is just the leftover land in the middle of all the mess. And let's say that this point right here is going to be listed as 4, 8. This point here is going to be listed as 15, 12. No, not 12. We're going to go 15, 18. This here we're going to list as 12, 3 is its location. Over here, 31, 14. This one we'll call it 24, 29. Over here we're going to call this one 1, 27. And 6, 18. Find the area of that thing.
So if you're doing like a lakefront,
You guys ready? See how you did? I'm going to start at the 4, 8 just because it's there. What would be next? 15, 18, and then 12, 3, 31, 14, 24, 29, 1, 27, 6, 18, and 4, 8. You missed the 15, 18. A lot of people missed that one tucked up in there. So 418 is 72, 15.3 is 45, 12.14 is 168, 31.29 is 899, 24.27, 648, 118 is 18, 68 is 48. What's that all add up to? 1898. How many of you got 1898? Good deal. Let's go the other way. 815 is 120. 1812 is 216, correct? Yep. 331 is 93. 1424 is 336. 29 and 1 is 29. 27 and 6 is what? 162? And 4, 8 is 72. Adds up to what? 1028. So 1898 minus 1028 is 870. Divided by 2 is 435 square units. Forgot to divide by 2? Kind of a neat little formula, isn't it? Neat little process. Not liking it so much. Yeah, we're looking for that sharp stick. I'm looking out across the room and I'm seeing full written across pretty much everybody's forehead. So there are 2 worksheets. I'm going to give you another worksheet here to go with the one I gave you just half an hour ago. There are going to be 2 worksheets for you to work on for Tuesday. I do expect you to take at least the next 20 minutes in class to work on them.